Eurypterids, sea scorpions, are an extinct group of arthropods related to arachnids that include the largest known arthropods to have ever lived. They are members of the extinct order Eurypterida, Chelicerata, which is the most diverse Paleozoic chelicerate order in terms of species. The name Eurypterida comes from the Greek words eury, meaning broad or wide, and pteron, meaning wing. This name was chosen due to the pair of wide swimming appendages on the first fossil Eurypterids discovered. The largest, such as Eurypterid, reached 2.5 meters, 8 feet 2 in length, but most species were less than 20 centimeters, 8 in. They were formidable predators that thrived in warm shallow water, in both seas and lakes, from the mid-Ordovician to late Permian, 470 to 248 million years ago. Although informally called sea scorpions, only the earliest ones were marine, later ones lived in brackish or freshwater, and they were not true scorpions. According to theory, the move from the sea to freshwater had probably occurred by the Pennsylvanian subperiod. Eurypterids are believed to have undergone ecdysis, making their significance in ecosystems difficult to assess, because it can be difficult to tell a fossil molt from a true fossil carcass. 4. They became extinct during the Permian-Triassic extinction event or sometime before the event 252.17 million years ago. Their fossils have a near-global distribution. About 24 families of Eurypterids are known. Perhaps the best-known genus of Eurypterid is Eurypteris, of which around 16 fossil species are known. The genus Eurypteris was described in 1825 by James Ellsworth Decay, a zoologist. He recognized the arthropod nature of the first ever described Eurypterid specimen, found by Dr. S. L. Mitchell. In 1984, that species, Eurypteris remips, was named the state fossil of New York. Pentacopterus decaurohensis, which lived as early as 467.3 million years ago, is the oldest described Eurypterid, with an estimated length of 1.83 meters, 6 feet 0 in. It has been described as the first real big predator. Body structure: Eurypterids have been formally described as follows: small to very large merostomes with elongate lanceolate, rarely trilobate body, prosoma, head, of moderate size, opistosoma, body, with 12 movable segments and styliform to spatulate telson, tail, with division commonly into 7-segmented proabdomen and 5-segmented postabdomen, prosoma, head. Appendages: 6, comprising 3-jointed chelicerae, walking legs, the last pair commonly transformed into swimming legs. Mouth central, bordered posteriorly by entostoma and metastoma. Operculum with median genital appendage, abdominal appendages plate-shaped with non-laminate gills. Ordovician Permian. The typical Eurypterid had a large, flat, semicircular carapace, followed by a jointed section, and finally a tapering, flexible tail, most ending with a long spine at the end. Eurypterid, though, had a large flat tail, possibly with a smaller spine. Behind the head, Eurypterids had 12 body segments, each of which was formed from a dorsal plate, tergite, and a ventral plate, sternite. The tail, known as the telson, is spiked in most Eurypterids, as in modern scorpions, and in some species it may have been used to inject venom, but there is no evidence that any Eurypterids were venomous. Most Eurypterids have paddles toward the end of the carapace and beyond, which were used to propel themselves through water. The suborder Styloneurina had walking legs instead of paddles. Some argue that the paddles were also used for digging. Underneath, in addition to the pair of swimming appendages, the creature had 4 pairs of jointed legs for walking, and 2 claws at the front, chelicerae, which were enlarged interrogatids. The walking legs had odd hairs, similar to modern-day crabs. Other features, common to ancient and modern arthropods of this type, include one pair of compound eyes and a pair of smaller eye spots, called ocelli, located between the other, larger, pair of eyes. Many Eurypterids had legs large and long enough to do more than allow them to crawl over the sea bottom. A number of species, particularly Eurypterids, had large stout legs, and were probably capable of terrestrial locomotion, like terrestrial crabs today. Studies of what are believed to be fossil trackways indicate that Eurypterids used entaphase, hexapodous, 6-legged, and octopodous, 8-legged, gaits. Some species may have been amphibious, emerging onto land for at least part of their life cycle. They may have been capable of breathing both in water and in air. A predatory arthropod known as protoconites, whose traces are found in Cambrian strata dating from 510 million years ago, is a possible stem group Eurypterid, and is among the first evidence of animals on land. The largest sea scorpion and the largest known arthropod ever to have lived is Eurypterid renanii, supported by the finding of a 46 cm, 18 in, long claw in 2007, indicating a body length of 2.5 meters, 8 feet 2 in. Relationships with other groups. Eurypterids have traditionally been regarded as close relatives of horseshoe crabs, Xiphosaura, together forming a group called Merostomida. Subsequent studies placed Eurypterids closer to the arachnids in a group called Metastomida. There has also been a prevailing idea that Eurypterids are closely related to scorpions, which they resemble. This hypothesis is reflected in the common name sea scorpion. More recently it has been recognized that a little-known, extinct group called Chasmotaspida also shares features with Eurypterida, and the two groups were sometimes confused with one another. A recent summary of the relationships between arachnids and their relatives recognized Eurypterida, Xiphosaura and Arachnida as three major groups, but was not able to resolve the phylogenetic relationship of any shared details between them. Another suggested the Eurypterids were sister group to the Chasmotaspids, with these two groups in turn sister group to the horseshoe crabs.